Hello my friends! Alright, so are you excited for this final tutorial where we visualize the results? Indeed, we're now completely done with the implementation. We don't have any more code to implement, related to the AI. So now is the time to just enjoy in our chair with a good coffee or a good tea the final results visualizing our AI landing on the moon. Remember, between those two flags, and we should see a super beautiful landing because indeed in 963 or more, specifically 863 episodes, we were able to get an average score of over 200, which is the desired performance. Alright, so now let's get into part 3, visualizing the results. As I said, we won't re-implement all this because this is more a visualization code than an AI code. However, what's interesting to note is that, as you can see, first we get the environment, then we initialize the state, we initialize done to false, the frames, but then the important thing I wanted to show you is that in this while loop that will run an episode, well, as you can notice, we only use, of course, the act method for our AI to play the different actions in order to land properly on the moon, and of course the step method of the environment, to get the next state, the reward, and whether or not we are done with the episode. But what do you notice here? What do you not see that we had before when we implemented the training loop? I think that's very important to highlight this. Well, of course, we don't see the step method from our agent because now our AI is trained, so we don't want to do any more training. We just want to be in inference mode, playing the different actions to land on the moon. I'm talking, of course, about this step method that we call from our agent, and that, remember, includes the learn method in order to do the training. All right, and as you can see, we don't see it here in this visualization code. Alright, so we only use the step function from our environment to get to the next state until the episode is done, and then at the end we save all the frames in a video, which we will have, of course, and also in order to show the video in this Colab notebook, well, we use this show video function to show the video just below in the console. Alright, that's all you need to understand in this code. We don't have to re-implement it, so let's just enjoy, let's just watch our AI land on the moon. Are you ready for this? Here we go. So what we only have to do now, unless your session has stopped, in which case you need to restart it by clicking runtime here, and then this time you can do restart and run all. Well, mine is still on, so I can just run this cell and visualize the result. So are you ready to see a beautiful landing on the moon? Here we go, 3, 2, 1, go. Let's run the cell, and in a second we will have the video. Actually, not a second, but in a few seconds we'll have the video, and also here you will see, well, first you see the model's parameters saved in this checkpoint.pth file. So that's from the previous code cell that we run. But soon enough, we will see a video here, which we'll be able to download on our machine and watch anytime we want. But of course, we'll also have it here in the console. And indeed, it's going to take a little time, but not that much because, we're not in training mode. We're just in inference mode. So right now, our AI is just playing the different actions over one episode. It is not doing any training, it is not doing any deep QLEARNING anymore. And since this code actually gathers all the frames together, well, it takes a little time to, gather these frames and include them into a video in the MP4 format. But the code is still running. All right. Oh, we are here, as you can see. The agent is still playing the actions. It is still returning the actions. And there we go, the code is executed after the agent played the actions. It was very fast to do the rest of this implementation. Are you ready to see the final video? Let's do this. 3, 2, 1, go. Here is our AI trying to land properly on the moon. It is very in control. It is playing some great actions. And look at this beautiful landing. That's a perfect landing. Oh my goodness. This is the first time I see such a perfect landing training this AI, because sometimes, it lands a bit on the right or, touching one of the flags. Here, it's really in between those two flags. That was a great one. So congratulations if you got the same thing. You probably got something very similar if you use the same architecture of the neural network. But there it is. That's a super beautiful landing. And as you can see, the video is also here if you want to download it. I'm gonna download this one to share it with you in the course. You just click on the 3 little dots and then download, and this will appear in our machine. All right, done. Let's have a look at it. Here it is. Here is the video. Let's watch it again in full screen, even if it will be lower resolution. But let's have a look one last time at this beautiful landing of our AI landing on the moon. Here we go. Super! So congratulations again. Now we're going to do one final tutorial where we're going to play a little bit with ChatGPT, trying to re-implement this with ChatGPT. Let's see if that's going to work. I can't wait to do that final tutorial with you of this part 1. And until then, enjoy AI. Hello my friends and welcome to the final tutorial of this module 1 on Deep QLearning. Congratulations for having reached so far by implementing together this Deep QLearning model. And speaking of which, now I want to say something very important, because in this tutorial we're going to build our Deep QLearning with ChatGPT. The really important thing that I want to say is that rest assured, all those 19 tutorials we just did together implementing ourselves Deep QLearning was completely worth it. It's very useful for you, because actually very few people can do it. Everybody can use ChatGPT to build a Deep QLearning model, but very few people can implement a Deep QLearning model as we just did. And therefore, that gives you a significant advantage as a data scientist or an AI engineer compared to people who are directly using ChatGPT to build an AI. Indeed, because we implemented the model together, you now know all the little details of the AI. You also know the foundations, the different layers of its mechanism, not only in terms of architecture, but also in terms of training. And therefore, that gives you so much more room for improvement compared to people who are directly asking ChatGPT to build an AI. So no worries at all. What we just did is extremely useful for you. It will make you one of the top AI scientists. But still, just for fun, let's build a Deep QLearning model with ChatGPT and see what we get. So let's start the chat. I'm going to say, hey, ChatGPT, can you please build a Deep QLearning model for the lunar landing environment? Okay, then I'm going to say, please implement it in PyTorch. By the way, PyTorch for deep reinforcement learning is undeniably much better than TensorFlow. Every expert will tell you that, even the experts working at Google. Today, this is a certainty. 3 years ago, I would have told you something different. But yes, today, PyTorch is the AI framework by excellence. All right. So please implement it in PyTorch, and please also include the code that generates the video of the trained agent at the end. Okay? Just like what we did, here we go. All right, so what do we have? Certainly. Below is a PyTorch implementation of a Deep QLearning model for the lunar lander environment from OpenAI's Gym. Yes, okay, so first it starts with the import, then it implements the DQN class, just like us. Okay, then it has a similar architecture to the one we use, but with different number of neurons in the fully connected layers. Then the forward function, of course, and then the DQN agent within a class. So we have the initialization of the parameter. It uses also an epsilon greedy strategy, okay? Then it initializes the Q network. Then, of course, it implements experience replay with that remember method. Then the act method, of course. Then replay, so that's for the experience replay again with the buffer memory. Then it updates the target model parameters with this update target model method. Then it initializes the environment, the state size, the action size again. You recognize the variables here. Then it creates the agent itself, and then it starts the training loop, looping over all the episodes and the time steps. And then it generates a video of the trained agent. And finally, we get that video. Okay, so at first sight, it seems pretty good, but I bet that whatever code you got, you probably got a similar code to this one. If you take this code and paste it in Google Colab, well, I'm pretty sure you will not get a performance training and mostly not that great results at the end, at least not as good as the ones we obtained, which is why I was telling you not only using ChatGPT for AI is easy, but besides, you will get much less great results than the ones we got thanks to the great understanding of AI we have while implementing our Deep QLearning model. But still, this is definitely some good work by ChatGPT. We definitely have a nice architecture here, a good class of the DQN agent integrating that epsilon greedy strategy as well as experience replay. Here is the epsilon greedy strategy. So yeah, that's not bad. And if you really want to be convinced that what we implemented is much better, well, I encourage you to try this code in a new Colab notebook, and you will see that the results will not be at that same level of quality we obtained while implementing on our Google Colab notebook our Deep QLearning model. Alright, So there we go. I just wanted to finish this section with a little bit of code generation within ChatGPT and, play a little bit with ChatGPT to see the kind of implementation it would return. Now, I just want to say two things. First, huge congratulations again for having implemented your first advanced AI of this course, the deep QLEARNING model for the lunar landing environment. You did some great first work there. And now the second thing I want to say is that I really look forward to seeing you in the second part of this course to implement an even more advanced AI model, which is the deep convolutional QLEARNING model, which is more advanced because indeed, instead of having a one-dimensional vector of input state, you will have multi-dimensional arrays representing images. Because this time, meaning for the environment we'll work on in this part 2, our AI will be playing a game with its own eyes, just like a human would play a game. And those eyes will be brought by the convolutional layers inside the neural network. It will be very exciting to implement. That's why I can't wait to see you there. And until then, enjoy AI.